Welcome to the GCSE Physics course. We will be covering the syllabus within Chapter 5. Chapter 5.1. Describe the structure of an atom in terms of a positive nucleus and negative electron. So we need to know that the nucleus of an atom is positive while the electron are negative. This therefore balance out the charge in an atom. Describe how the scattering of alpha particles by thin metal foils provides evidence for the atomic structure consisting of neutrons and electrons. The experiment was carried out by shooting alpha particles through a thin foil of gold. As a result, 99% of the alpha particles passed straight through while only few deflected off. Rutherford concluded that the nucleus of an atom had a small diameter compared to its atom, and that most of the atom's mass were gathered at its nucleus. Chapter 5.1.2. Describe the composition of the nucleus in terms of protons and neutrons. We must note that the nucleus of an atom contains protons and neutrons. We must also note that the protons are positive and that the neutrons do not have an electrical charge. The Euclid notation. The Euclid notation is a way to determine specific information about an element including its nucleon number, proton number and its element symbol. In the diagram, A represents the nucleon number, Z represents the proton number and the big X represents its element symbol. If we look at the example below, we can see how the numbers have its own meaning and that it shows specific information about sodium. Use and explain the term isotope. Isotope is the same element but with different amount of neutrons. State the meaning of nuclear fission. Nuclear fission is the splitting of a nucleus. The neutrons is split into smaller nuclei. It also forms some binding energy which holds the nucleus together. State the meaning of nuclear fusion. A reaction which two smaller nuclei collide together with high speed and form a heavier nuclei. It also results in the release of energy. Chapter 5.2. Demonstrate understanding of background radiation. Background radiation are radiation that comes from things we barely notice around us. Examples of them are rocks and soils, radiation rays and living things such as plants. Describe the detection of alpha particles, beta particles and gamma particles. To do this, we use a Geiger-Müller tube. It is filled with gas at low pressure and has a thin mica end. It has a central electrode and a voltage supply is connected throughout the tube's casing. When a radiation enters the tube, it will produce ions gas. Ions will enable electricity to conduct and will produce voltage pulse. This will then be measured since each radiation have different pulses. Characteristics of the three kinds of radiation emission. Alpha radiation. Alpha radiation is positively charged and contains two protons and two neutrons. It travels the slowest out of the three types of radiation and it is not very penetrable. Beta radiation. Beta radiation is negatively charged and is only an electron. It travels faster than alpha radiation but slower than gamma radiation. It have a fine penetration ability. Gamma radiation. Gamma radiation have no charge and is an electromagnetic wave. It travels at the speed of light and have a great penetration ability although it can be reduced by thick materials. Characteristics of the three kinds of radiation emission. Alpha radiation is used to detect smoke. The smoke absorbs the alpha radiation, altering its ionization and trigger the alarm. The ionization of beta radiation is used for tracers and scanning the thickness of materials. Doctors use this for medical imaging and industries also use this to monitor thickness of materials like paper, aluminium, gold, etc. Gamma radiation is mostly used in treatment of cancer, testing equipment and sterilizing medical instruments. Penetration ability. In the diagram, we can see that alpha radiation have the least penetration, then beta and then gamma with the best penetration ability. Describe the deflection in electric fields and in magnetic fields. Because beta radiation is negatively charged, gamma radiation have neutral charge and alpha radiation have a positive charge, as the image stated. The deflection course will be like this. Give and explain examples of practical applications of alpha, beta and gamma emissions. They're used in smoke detectors, killing cancer cells, measuring materials thickness, tracers and sterilizing medical instruments. Chapter 5.2.3 State the meaning of radioactive decay. Radioactive decay is the breakdown of the atomic nucleus. This results in a release of energy and matters from the nucleus. Use equations involving Euclid notation to represent changes in the composition of the nucleus when particles are emitted. When atoms emit alpha or beta radiation, its nucleus will change because it becomes the nucleus of a different element. This is due to the number of protons determining the element. And since protons' number will change during the radiation, its nucleus will change. The examples below will help explain this. Chapter 5.2.4 Half-life. Half-life is the calculation of the times it takes for the number of nuclei to halve. If we look at the graph, we can see a deduction from 80 to 40 in 2 days. So the half-life is 2 days because it takes 2 days for the counts per minute to halve. Chapter 5.2.5 Recall the effects of ionizing radiations on living things. These radiations are very toxic to living organisms because they can damage living cells. This is done by breaking down molecules into smaller fragments producing ions. Ions can take part in other chemical reactions that is harmful to living cells and kill them. Describe how radioactive materials are handled, used and stored in a safe way. To handle radioactive materials, we should wear protective clothing, keeping as far away as possible, exposed to it as short as possible and keep radioactive materials in lead containers.